I have written a book about a new physical theory which promises to unite quantum mechanics with relativity and gives us a new way to think about the speed of light. If my theory is correct, then almost everything that is taught in relation to Einstein's theory of relativity is wrong, and it will need to be revised. I call this new theory the supervelocity and selection theory of light. I think it's best to begin by describing the essential difference between special relativity and the supervelocity and selection theory of light. According to special relativity, time and space must both bend in order to allow observers who occupy different inertial frames of reference to see the same light move at the same relative speed. By contrast, according to the supervelocity and selection theory of light, no time dilation or length contraction is necessary in order to reconcile these divergent observations, because the light that is seen by each observer is not really the same light. Rather, the light that each observer sees has been selected independently by each observer. The main advantage that the supervelocity and selection theory of light has over special relativity is that it explains the observer-centered and observer-dependent nature of the speed of light much more efficiently and effectively than does special relativity. It also holds that the speed of light is not a cosmic speed limit. The supervelocity and selection theory of light contains 4 core postulates. Number 1. An object has a defined velocity if and only if it has a defined location in velocity space. Number 2. Latent light occupies a superposition in velocity space. Number 3. Each observer independently selects manifest light from the available latent light by virtue of that observer's objective location in velocity space. And number 4. All of and only the latent light that resides in velocity space at a distance of c from the observer is selected. In addition to these 4 postulates, the supervelocity and selection theory of light also includes the 2 core postulates of special relativity. The foundations of special relativity are based on the results of the Michelson-Morley experiment, which found that the speed of light does not change depending on the orbit of the Earth or the direction of the motion of the light. Just as with special relativity, the supervelocity and selection theory of light is also founded on the idea that the laws of physics are the same in all inertial frames of reference, that light is always observed to move at c relative to each observer, and that the velocity of a light source has no effect on the observed velocity of the light that it emits. According to the supervelocity and selection theory of light, light is neither a particle nor a wave, but a superwave as seen from a specific vantage point. Light is even more wave-like than either surface waves or sound waves. By comparison to a superwave, an ordinary wave is relatively particle-like. Now, I want to point out that while supervelocity is a novel term, it's not an entirely novel concept in quantum mechanics. A supervelocity more or less corresponds to what would be referred to as a quantum superposition of momentum eigenstates in the language of quantum mechanics. The supervelocity and selection theory of light differs from special relativity in that it does not rely on Einstein's light-based definition of simultaneity, on his reasons for proposing inertial time dilation and length contraction, on the idea that the speed of light is a universal speed limit, or on the Minkowski spacetime manifold. What I am doing with this theory is reaffirming the roots of special relativity while extending it in a new direction that is informed by quantum mechanical insights which were not available to Einstein in 1905 when he first introduced special relativity to the world. I am uniting relativity with quantum mechanics in a novel way. In order to construct this new theory, it was absolutely necessary for me to identify the following three interconnected distinctions. Firstly, I needed to break the term inertial frame of reference into two related concepts. Here I draw a necessary distinction between location 0 in the coordinate system and the location of an observer in velocity space. The configuration of the coordinate system is relatively subjective, variable, and abstract, while the location in velocity space of an observer is relatively objective, fixed, and concrete. Secondly, I needed to break the term distance into two related concepts. Here I draw a necessary distinction between the frame-dependent displacement between a point of departure and a destination, and the true distance between those 2 points. The frame-dependent displacement is relatively subjective, variable, and abstract, while the true distance is relatively objective, fixed, and concrete. Thirdly, I needed to break this term light into two related concepts. Here I draw a necessary distinction between the manifest light, that is only visible to observers from within a specific location in velocity space, and the latent light, which constitutes the rest of the light. The manifest light must have a relative speed of 299,792 kilometers per second, which is specifically tailored to the location in velocity space of a particular observer, while the latent light occupies the remaining locations in velocity space. The observer always occupies the average location of the manifest light in velocity space, which would correspond to the center of a light bubble in velocity space. Now that we have the concept of velocity space, the concept of true distance, and the concept of latent light, we can assemble an objective model of what is really happening with light in a way that isn't helplessly dependent on a subjective and arbitrary perspective. I find it helpful to rely on an analogy of a rainbow in order to get across the main idea behind this theory. The arc of a rainbow appears to stand in a particular position, but it really doesn't. And if you doubt that, just try to find the pot of gold or the leprechaun. By the same token, the spherical wavefront of a flash of light appears to expand outwards in all directions at a particular speed, but it really doesn't. Starlight can also serve as a helpful analogy. When observing a bright but distant star, let's use Deneb as an example, an observer who is located in a particular position will only be able to see the light that traveled directly from the point of origin to their specific location. That is, they can only see the light that traveled in one very specific direction, while the rest of the light from that star is not observed. Similarly, when observing a bright but distant star, an observer who is coasting in a particular inertial frame of reference will only be able to see the light that is traveling at roughly 299,792 kilometers per second relative to their inertial frame of reference. That is, they can only see the light that traveled at one very specific speed, while the rest of the light from that star is not observed. Two different observers, who are each located in two different locations, will see the same light move in two different directions. They will each see the portion of the light that moved in a direction that is specifically tailored to their particular location in space. In a relatively superficial sense, both observers will see the light moving in exactly the same direction, because according to both observers, the light moved directly towards me. Similarly, two different observers who are each moving in different inertial frames of reference will see the same light move at two different velocities. They will each see the portion of the light that moved at a velocity that was specifically tailored to their particular inertial frame of reference. In a relatively superficial sense, both observers will see the light moving in exactly the same speed, because according to both observers, the light moved at 299,792 kilometers per second relative to me. An important part of what it means to be in a particular location is to only be able to see a very small proportion of the total light and only that light which moved in a particular direction such that it was able to pass through the narrow opening of your pupil. Multiple observers in different locations can also integrate their seemingly contradictory observations in order to confirm that the light must have moved in multiple directions at the same time. The direction of the motion of the observed light was actually determined by the relative position of the observer. Similarly, an important part of what it means to be in a particular inertial frame of reference is to only be able to see a very small proportion of the total light, and only that light which moved at a particular speed such that it was able to interact with the light-sensitive cells in your retina. Multiple observers in different inertial frames of reference can also integrate their seemingly contradictory observations in order to confirm that the light must have moved at multiple speeds at the same time. The speed of the motion of the observed light was actually determined by the relative velocity of the observer. Just as light spreads out and moves in all directions in position space, light also spreads out and moves at all velocities in velocity space. Just as an observer sees different light as they change their location in position space, an observer also sees different light as they change their location in velocity space. Now, I have a general impression of why this theory is going to be difficult for many people to accept. You're probably familiar with the Hydra from Greek mythology. The Hydra is a difficult beast to slay because it has the ability to regenerate. You can cut off one or more of its heads, but if you don't manage to kill the beast, then its heads will just grow back. Special Relativity has a similar ability to regenerate, and this makes it very difficult to defeat. In my assessment, this Hydra of Special Relativity has 7 heads, which I have enumerated and described. Hydra head number 1. Confusion between the objective location of an observer in velocity space and the arbitrary location of the zero in velocity space. The common word inertial frame of reference is normally used to refer to both of these concepts, and it also ties them together. Subjective framing is therefore tied to an objective location in velocity space, and in this way the relative versus absolute dichotomy is conflated with the subjective versus objective dichotomy. In order to avoid confusion, these two dichotomies must be treated as separate and distinct, and the use of velocity space will assist us in distinguishing between these dichotomies by giving us a way to model velocities which are at the same time relative and objective. Hydra head number 2. Confusion between the objective true distance between two objects and the frame-dependent displacement of a moving object. Unlike the frame-dependent displacement, the true distance does not depend on an arbitrary frame of reference. Conflation between these two concepts makes the true distance appear to be just as subjective as the frame-dependent displacement is, and this confusion is also fed by the assumption that distance can only be derived from multiplying velocity by time. Further confusion is caused by the assumption that distance rests on a subjective assessment of simultaneity, which in turn depends on a relative velocity. It's important to keep in mind that there are other ways of both measuring and defining distances which are relatively stable and objective. Hydra head number 3. Confusion between manifest light and latent light. Because the existence of latent light had not been previously acknowledged, it was therefore assumed that the manifest light that one observer sees from one location in velocity space must also be the same manifest light that another observer sees from another location in velocity space. The reality is that the particular latent light which manifests for two different observers will differ depending on where each of them is in velocity space. The two observers are not both viewing the same light, and so there is no discrepancy that needs to be reconciled. Hydra head number 4. This is the idea that the speed of light can be simultaneously characterized as fixed relative to the observer and objective. If any finite speed is both fixed and relative to the observer, then it must be subjective. For any finite speed to be objective, then it cannot be both relative to the observer and fixed. I use an analogy with a rainbow to make this point more clear. Hydra head number 5. The idea that objects or observers are able to move through space itself, or relative to space itself, along with the idea that space itself can move, stretch, expand, or shrink. This is a subtle resurrection of the idea of an absolute inertial frame of reference, and this contradicts the first postulate of special relativity. Hydra head number 6. The idea that the relative and finite speed of 299,792 kilometers per second also functions as a speed limit. This special speed is not only considered to be the speed of light, but also the speed of gravity waves, causality, and information. This would have been plausible if 299,792 kilometers per second had been either absolute or infinite. But because it is neither absolute nor infinite, then it cannot function as a speed limit. Hydra head number 7. The idea that symmetry is an epistemological limit. The question of who is really in inertial motion or who is really stationary is frequently taken as a meaningful question in this context. This is also a subtle resurrection of the idea of an absolute inertial frame of reference. In the context of the twin paradox, I use the analogy of a poker game to expose the absurdity of this conception of reality. Now I'd like to close this introductory video with 7 questions to meditate on. Number 1. Whenever you hear it correctly stated that it's impossible to catch up with a light beam, remember that it's also impossible to touch a real rainbow. Now, why might that be? 2. Whenever you hear it correctly stated that it's impossible to travel fast enough to escape from a light beam, remember that it's also impossible to travel fast enough to escape from your own shadow. Why might that be? Number 3. Whenever you hear it incorrectly stated that nothing can travel faster than 299,792 kilometers per second, remember that it's always possible to accelerate at any rate and in any direction that you want to without limits. Now, why might that be? Number 4. Whenever you hear it misleadingly stated that the speed of light is a constant, remember that this same property also applies to the direction of light, because for light to be observed, it must always be pointed directly towards the observer. Now, why might that be? Number 5. Whenever you hear it misleadingly stated that the speed of light is fixed, remember that so is the apparent distance between an observer and a rainbow. Now, why might that be? Number 6. Whenever you hear it stated that each observer thinks that the other observer's time is dilated, remember that each observer also thinks that the other observer appears to have shrunk, because more distant objects always look smaller. Now, why might that be? And 7. Whenever you hear it stated that the maximum speed is the finite value of 299,792 kilometers per second, remember that the maximum visual angle is also the finite value of 180 degrees. Objects cannot appear to be any larger or closer than 180 degrees. Now, why might that be?